on the current carrying conductor in a magnetic field. We are having a conductor whose length is capital L, area of cross section is capital A, and the current is flowing in this direction plus x direction. Here the magnetic field is in z direction, which is perpendicular to the current, and we have to find the what is the force on this conductor. Now, if small n is the number of electrons per unit volume, the volume of cylinder will be equal to area of cross section multiplied by the length. So volume will be equal to L into A. So total number of charge containing in the conductor will be equal to n, small n, into volume A into capital L. So this will be the total number of charges present in the conductor. And what will be the total charge? We will multiply the charge of the electron. So the total charge in the conductor Q is equal to minus E into N into A into capital L, where minus E is the charge of the electron. So now what will be the force on the electron which is moving? So force on the electron will be Lorentz force, and Lorentz force will be equal to Fb will be equal to Q Vd cross B. Vd is the drift velocity. It is a Vd is the drift velocity of the electron, and B is the magnetic field. So the Lorentz force Fb will be equal to Q multiplied by the vector product of drift velocity and the magnetic field. Now, what will be the Fb? Fb will be equal to minus n. We substitute the value of Q is equal to minus n E A L multiplied by Vd cross B. So this will be field. So now here we can write this is equal to N E B minus L into Vd vector cross B. Now the direction of Vd is opposite to the length. Length is in this direction and Vd is the opposite direction. So L into V minus L into Vd will be equal to L vector into Vd. So if we change here the vector from minus L Vd to L vector Vd. So here it will be Fb will be equal to NEAVD bracket L cross B. Now what is this? NEAVD. This is the current. So the current passing through the conductor is equal to NEAVD. So we will substitute I. So Fb will be equal to IL cross B. Or we can say this is equal to ILB sin theta. Because the cross product will be equal to L into B into sin theta, where theta is the angle between L and B. In this case, if Fb will be equal to 0, if theta is equal to 0 or pi, when theta is equal to 0, sin 0 is equal to 0. So Fb will be equal to 0. When theta is equal to pi, sin pi is equal to 0. So, okay. So the magnetic field will be equal to 0 if theta is equal to 0 or pi. Theta is the angle between L and B. Now second case, when the angle is pi by 2, sin pi by 2 is 1. So the force will be Fb, the force will be maximum and its value will be equal to ILB sin 90, which is equal to IL into B. So this will be the maximum force, and direction of this force will be perpendicular to the plane containing L and this is the direction of L, this is the direction of B. So this is in the X direction, this is the Z direction. So the force will be in the Y direction, which is perpendicular to the plane B and L. So now we can give the direction of force by Fleming left hand rule. Now what is the Fleming left hand rule? If we take the left hand, this is our left hand, then this is your thumb, this is your forefinger, this is central finger. So forefinger is field, forefinger F for field, central finger C for current, and thumb will be the direction of force. Or we can say it is a FBI. B is the this is F is the direction of force. This is the F in this direction. This will be the field in this direction. So F, B field and I current. So we can find the force on a conductor by left hand rule. Here the since L and B both are perpendicular to each other, so the direction of the force will be perpendicular to X and Y plane, that is in the Y direction. Next topic, that is the magnetic force on current carrying parallel conductor of infinite length. So we are having two conductors AB and CD. Their length is infinite. The current I1 is passing through AB from B to A, and current passing through CD will be equal to D to C. So this is the direction of I1 here. His I2 is current here. Now if we consider any small segment, small L on the wire CD, then what will be the magnetic field? At this wire, the distance between the two wires is small d. So the magnetic field will be given by B1. Here the magnetic field due to the wire 1 number is mu0/4 pi 2 I1 current divided by D. I1 is the current here passing through this, and D is the distance between this wire and this wire. So, and the direction of magnetic field will be given by right hand thumb rule. So, this is the direction of current. So, it will be in the inward direction. So, the direction of magnetic field will be inside the board. So, it is represented by cross. So, what will be the force? The force on wire number 2 due to the current in the wire number F21. F21 is current force on second wire due to one wire. This will be equal to current in this wire I2 into L into magnetic field as we have derived here, and angle is 90. So sin 90 is equal to 1. So we substitute the value of B1. So the force F21 will be equal to mu0/4 pi 2I/D into I2 into L. So this will be the magnetic field force here, and the direction of force will be given by the left hand rule. So now here the direction of field is inside and current is upside. So the force will be towards the left. So this force will be towards the AB wire perpendicular to it, and this direction will be given by the Fleming left hand rule. The magnetic field is downward, current is this one. So force will be in the perpendicular direction. So this force will be from C to D normally. So this will be the force will be there. Now, if we want to find the force on the wire AB due to current in passing I2 in CD. So here we can a small element, small l, capital L, the length between the U and V. Now what will be the force here? We have to find the force on this due to this magnetic. What will be the magnetic field here? The magnetic field here will be equal to, we can find the magnetic field is equal to mu 0 bata 4 pi 2, current is I2 here, distance is T. So the magnetic field at this point due to the current in the second wire will be equal to mu 0 bata 4 pi 2 I2 bata D, and its direction is also given by the Fleming, it is given by the right hand thumb rule. So what will be the direction? Direction will be again inside this. The current is here. So the magnetic field will be in this direction. So the magnetic field due to this conductor or here will be equal to B2, and its direction will be perpendicular to the board inside it. So what will be the force? Force on this conductor wire AB due to the current in CD can be given by Fleming left hand rule. So the force on wire number 1 due to current in the second wire, that is equal to F12 will be equal to I into L into B2. I1 is current here, L is the length of the segment, small element, and B2 is the magnetic field at this point due to the current in CD. We substitute the value of B2 here, then F12 will be equal to mu 0 bata 4 pi 2 I2 bata D into L into I1. So the value of its direction will be from, this will be F12 will be in this direction. It is towards the CD. By the Fleming left rule, we will apply the Fleming left rule. So this is the direction of field and this is the direction of current. This is the direction of field, this is the direction of current. And so it will be in this direction. So the force on AB wire will be towards CD. So the magnitude of F12 and F21, they are equal, and that is equal to mu 0 4 pi 2 I1 I2 into L bata D. So these two forces are equal. So but their direction is opposite. F12 is in this direction towards CD and F21 is towards AB. So their magnitude is same, but their direction is opposite to each other. So we will say F12 is equal to minus F21, or the magnitude of F12 will be equal to magnitude of F2. Their value will be same, and this magnitude will be equal to mu 0 bata 4 pi 2 I1 I2 L bata D. So this will be the. Now here we have taken both the current. Suppose we are having a fixed it. This is AB and this is CD. Current is in the same direction and they are parallel to each other. Then there will be force. Then due to this, the shape of the current will be there. Due to the attractive force, it will be like so. When the current passes in the same direction, there will be force of attraction between the wire and the shape will be like this. Whereas if the current passing through AB is in this direction and we reverse the direction of CD, then there will be repulsion. Here the force F12 will be in this direction and F21 in this direction. So they are opposite. So the shape will be like this. So when the current is passing through the parallel wire in the same direction, there is the attraction, and when the current is passing in the parallel wire in opposite direction, there is a repulsion. Now we can define the standard value of 1 ampere current. Now if we are having two wires, their current is equal and it is 1 ampere, the distance between the two wires is 1 meter, then the force F12 divided by L, we find that will be equal to mu 0 bata 4 pi into 2 I1 and I2. This is 1 ampere, this is 1 ampere, and D is also 1 meter. So F bata L will be equal to 2. This will be equal to mu 0 bata 4 pi is 10 raised to minus 7. So 2 into 10 raised to minus 7 Newton per meter. So we can say that 1 ampere current is that current which is passing through the two thin infinitely long conductor placed at a distance 1 meter, have a force of attraction or repulsion equal to 2 into 10 raised to power minus 7 Newton per meter. So here force per unit length, we divided by the length. So force per unit length will be equal to 2 into 10 raised to minus 7 Newton per meter. So once I have repeated, what is the standard 1 ampere current? Standard 1 ampere current is that current which is passing through the two parallel conductors of infinite length kept at a distance of 1 meter, experience a force per unit length equal to 2 into 10 raised to minus 7 Newton per meter. So in this way we can define the 1 ampere current. Okay.